Okay, so question one on chapter 4 for the study plan. Question one says a 5 kilogram block and a 4 kilogram block are connected by 0.6 kilogram rod. The lengths between the blocks and the rod are denoted by A and B. A force F is applied to the upper block. So it says the blocks and rod assembly move downward at a constant velocity. The applied force is closest to 92 newtons, 94, 96, 90, or 88 newtons. So as always, just write out what you're given, right? So we are given the mass of block A, which is 5 kilograms, the mass of block B, which is 4 kilograms, and the rod mass of R is 0.6 kilograms. If also what could help also is to write your summation of forces. So the summation of forces will be um your wait, what color can I use? Okay, never mind. So it'll be your no, it'll be F minus the weight. Okay. So it's gonna be your summation of forces is gonna be negative force is mass times acceleration. So mass equals F minus mg. mg. When you isolate F, you will have minus m a the y direction plus mg. So this so you, just add up all the masses, right? We're adding all the masses in the right direction, so it's gonna be your m of A, your mb, m of the rod. So it's gonna be 5. It'll be 5 plus 4 plus 0.6 plus 9.8. Oh, hold on. Actually, technically, okay, I see now my error. So there's no acceleration. So this is 0. So this cancels out. So you don't need this. Actually, you do need that, but you don't need yeah. Since there is no acceleration, thus that cancels out because everything times 0 is 0. This is 0. So your force will be just the mass times gravity. So just add up all your masses. So it's 5 plus 0.6 plus 4. Divide that by 9.8, which comes out to 94.08 newtons. If you want to round off, you can. It'll be 94.1. So it'll be the answer will be B, 94.